Hi everyone, my name is Annette and this is Chemistry at a Glance. So the aim here is to explain all the topics in the Chemistry AS level as simply as possible, and I explain all these past paper questions as well, and I'm trying to do it simple so that everyone can understand it. I know they sometimes use in this difficult words, but I'm trying to use easy words for you to like chemistry and understand it fully. And in this video, we're going to practice some past paper questions on the periodic table, the structure, trends, and S-block elements reactions. So without further ado, let's just start with them. So the barium chloride is a highly toxic compound that is frequently used in the laboratory. Aqueous barium chloride can be used to test for sulfate ions in solution. Write an ionic equation for the reaction that occurs when aqueous barium chloride is added to a solution containing sulfate ions. So we only write in the ionic equation. So we're using barium chloride and sulfate ions. So in barium chloride, we have barium 2 plus and chlorine minus. But we're only caring about barium ions now. So we put barium 2 plus, aqueous, plus it's added to a solution of containing sulfate ions. So we put in the sulfate ions as well. And what we are trying to find is the product that's going to be formed. So as it says, the barium chloride can be used to test for sulfate ions. It can be used for this testing because the barium will break bonds with chlorine and join sulfate. So it will become barium sulfate, and it's going to be precipitate. That's why it's going to be solid. So we have barium plus, 2 plus, sulfate 2 minus. They're changing these, so it would be Ba2, SO4, 2. But because they're both the same, we can just cancel this out to be barium sulfate. That's how I work out the ion equation. Put both of them, both of the ions, take the top to the bottom, top to the bottom, across, and then because they're both 2, they're just going to cancel each other out, and that's what you're left with. You're not putting the ion signs anymore because you only do this when the ion is in aqueous state, not a solid. If it's in solid, it just stays like this. Okay, so give the observation expected for a positive result in this chemical test. So this topic is full of different tests, different results, different precipitate, colors, and all this stuff. If you're not sure about all the reactions you have to know, visit my website. I write exactly every single reaction that you have to be able to know for your AS level chemistry. And this is one of them. So the test of group 2 metals with sulfate ions. When you add sulfate to barium, it is insoluble. The solubility of metals with sulfates increases up the group. So barium is completely insoluble and magnesium is soluble. That's why barium is the best one to use for testing sulfates, because it will not be soluble, so it's going to create precipitate. So the observation expected would be the white precipitate. Because barium is insoluble, that's why you're going to see this solid. Okay, so the next part says, a solution of barium chloride can be identified using separate tests for barium ions and chloride ions. A flame test can be used to prove that the solution contains barium ions. State the flame color that would be seen. So flame colors is another test, which I also explain in my blog, so go and visit that. I leave the links in the description box below. But the color, the flame color of barium is apple green. This is all the stuff you have to just remember. You just want to remember them, or like this topic is best to do right before your exam, because you just have to remember all the colors and all these observations and conditions, and then you'll be all right. So the next part, it says, give a chemical test to show that the solution contains chloride ions. Your answer should include the reagents and expected observations. So this is another test. This is actually the silver nitrate test, because you add silver nitrate, which is the reagent, and if chlorine is present, you get a white precipitate. If it was bromine, you would get a green precipitate, and it was iodine, you would get yellow precipitate. This is just another test. This topic is not so much that I can explain, I can just go through the topic with you, but my website would be much helpful for you now. If you're struggling to remember all these colors, which I did when I was doing my A-levels, I used to just put them all on the post-its and hang them all around my room and everywhere I would go, and then every time I would pass them, I would read them and it would just stick in my head. Try this if you want. So this question says, explain the fact that the melting temperature of sodium is much lower than the melting temperature of magnesium. You should include reference to the types of bonding involved and how this bonding affects melting temperatures. You may include a diagram if you consider it helpful. So let's start with sodium. Sodium has one electron in its outer shell, in its valence shell. So it has one valence electron. Magnesium is in group 2 and it has 2 valence electrons. And as you know, when you have metal plus another metal, you get a metallic bond. Metallic bond is a bond because the atoms donate the electrons, the outer electrons, to the localized system, and that's how the bond is held together, due to this delocalized electrons. So magnesium can donate 2 electrons to the delocalized system, and sodium can only donate 1 electron. When magnesium adds these 2 electrons, the bond is much stronger than when sodium adds just 1 electron, because the more electrons there is, the stronger the bond is. So if the bond is much stronger, more energy needs to be put in for this bond to break. And boiling and melting is the breaking of these bonds. So for a compound to melt, you have to break all its bonds first. And for magnesium, it's going to be much harder. That's why it has a higher melting temperature than sodium. Okay, next question. The table shows some of the elements in the periodic table together with the melting temperature of the most important solid form of the element. State which of the elements shown will not be solids at room temperature. As you can see, for neon, 25 degrees Kelvin. Sorry. I think that should say degrees Celsius. No, sorry, Kelvins. So as you know, 0 degrees Celsius equals 273 Kelvins. So if the Kelvins is actually 25, then the temperature will be well below 0 degrees. That means that at room temperature, it's already going to be boiling. So that's why neon will not be solid at room temperature. Argon, again, it's lower than 0 degrees. So at room temperature, it's already going to be boiling because that's the boiling temperature of argon. Next one is chlorine, 172. That's still below 0. So at a room temperature, it's already going to be boiling as well. Next one is sulfur. Sulfur is different because its Kelvins is 392. That means it's actually 119 degrees Celsius. If it's 119 degrees Celsius, that means that at room temperature, it's going to be solid because it will need 119 degrees to boil. So it's no longer solid at room temperature, and any of them, they're still not going to be solids at room temperature. So just these three. So next part says, explain in terms of bonding and structure why silicon here, and carbon have the highest melting temperatures. As we can see, both carbon and silicon have 4 outer electrons. So anything before this will have smaller number of electrons, so it will want to lose these electrons. Anything above that will have a higher number of valence electrons, so it's going to want to attract the rest of them. Carbon and silicon, they usually form covalent bonds because they will have to either donate these 4 electrons or attract another 4, which is difficult. So they usually form covalent bonding. And due to this covalent bonding, they are stable. Because they're going to involve these 4 electrons in bonding, there's going to be a lot of energy needed for it to break. So 4 electrons involved in bonding for both carbon and silicon because they are in group 4. Therefore, a lot of energy needed to break it. Next part. Explain why neon and argon have the lowest melting temperatures. So here's our neon and here's our argon. So, as you know, from the periodic table, neon and argon are both in group 8 or group 0, however you want to call it. That means they have a full shell of electrons, so they don't react with anything else. So the only forces that are holding it together are the van der Waals forces. And van der Waals forces are weak. They are the weakest forces. So they're going to be easy to break, so they're going to have the lowest melting temperature. Next one says, explain why the melting temperature increases for the sequence sodium, magnesium, aluminium, even though all 3 involve metallic bonding. As you can see, sodium, magnesium, aluminium, the melting temperature increases. So as we talked about it before, sodium will have 1 electron involved in bonding. Magnesium will have 2 electrons involved in bonding, and aluminium will have 3 electrons involved in bonding. As you know, aluminium has the highest melting temperature, sodium the smallest out of these 3. And this is because in aluminium, 3 electrons will be involved in this metallic bond. The more electrons there are, the stronger the bond. And the stronger the bond, the more energy will be needed to break it in order to melt the substance. Here's the next couple of questions for you, and it says, state why melting temperature for silicon is lower than that for carbon, even though they involve the same bonding and structure. Let's go back to this page. I'm going to put it right here. We've got our silicon and we've got our carbon. And now we got to say why that for silicon is lower than the melting temperature for carbon. The reason for this is even because they're both in the same group, carbon is above silicon. So carbon is in period 2, silicon is in period 3. That means carbon is smaller than silicon. Because it's smaller, it can fit closely together with other atoms and make stronger covalent bonding. So as I said, come closely with other atoms and make therefore stronger covalent bonds, because it's going to be really stuck together all around. Because carbon is smaller than silicon, you will need much more energy to split up this bonding. Here is the last part of this big question. State why the melting temperature of argon is higher than that for neon. So argon here, neon here. Why this one is higher than that for neon. So as we said before, they both in the same group, group 8 or 0. So they have 8 electrons, both of them. They both not reactive at all. They just have these van der Waals forces. And because in this instance, argon is bigger than neon, it's going to have more of these van der Waals forces. And even though they're weak, this one is weak and this one is weak, but this one has more of these weak forces, so it's going to have a higher melting temperature because more of them to break than neon. So although they are reactive, argon is bigger, so it's going to have more van der Waals, so more of them to break than neon. Next question. Basic magnesium carbonate has the formula MgCO3.MgOH2.3H2O. On strong heating, it decomposes, given 3 products, 2 of which are carbon dioxide and water. Give the equation for the thermal decomposition of basic magnesium carbonate. So the equation would look like this. Magnesium carbonate, magnesium OH2 and 3H2. We are told it's going to give carbon dioxide plus water, and the last part will be magnesium oxide. I already wrote 2 on this side for the magnesium because this is the only magnesium on this side and we have 2 magnesium on this side. So what we're going to do is just balance this equation now. So magnesium on this side is 2 at the beginning, carbon is 1, oxygen is 8, and hydrogen is 8. 1 carbon, 3, 4, 5, 6, 7, 8 oxygens and 8 hydrogens. On this side, we are starting with 2 magnesium because I already wrote this one down. We have 1 carbon, we have 4 oxygens, 5 oxygens, sorry, 5, and we have 2 hydrogens. So we are aiming to have 2 magnesium, so they balance, carbons balance, oxygens don't balance, and hydrogens don't balance. So you have hydrogens here and oxygens in these 2 places, so I'm going to start with hydrogens first. We have to have 8, and now we have 8 of them. Now we just got to balance the oxygens. We have 8 on this side as well, and we've got 4, 5, 6, 7, 8 on this side now as well. So here's our equation balance. Okay, here's the last but one question, fill in the blanks. So in the periodic table, the values of ionization energy and electronegativity, something down a group and something across the period. So we know fluorine is the most electronegative element there is. And I'm going to tell you that the electronegativity and ionization energy decreases down the group and increases across the period. This is because down the group the element becomes bigger. That means that the electrons, the outer electrons, will be further away from the nucleus. That's why the nucleus will no longer attract these electrons as much as in the smaller element. And it increases across a period because even though the shell is still the same, there is more and more protons in the nucleus, so they attract these electrons more because the nucleus will have a higher positive charge, so it will really attract these negative electrons to itself. That's why the fluorine is also the most electronegative, because it's in the second period and is the one across the period, the further across the period, and the highest in the group. Okay, now we got a solubility. Solubility of group 2 hydroxides, something down the group, and the solubility of group 2 sulfates, something down the group. So they work opposite actually. So the solubility of group 2 hydroxide increases down the group, so the magnesium hydroxide is completely insoluble, it creates precipitate, And as you go down the group, the solubility increases. However, of the sulfates, it decreases down the group. So barium is completely insoluble, it's going to be solid, and magnesium is the most soluble. This is all the, I'm going to say laws, or like the observations that are constant. You're always going to get this, and you just have to know them off by heart. And last bit, redox, which is oxidation and reduction. Reactions involve the transfer of something from one agent to another. So the redox equations is all about the transfer of electrons. A substance that gives we are given electrons, one electron to another substance is called a. So when a substance loses electrons, we either have oil or reg. I always use that. Oil, which is oxidation, is loss, or reduction is gain. So in this instance, we said that it gives one electron to another substance, so it loses an electron. So it oxidizes, so it's being oxidized. If it's being oxidized, that means it's a reducing agent. Okay, so let's be clear. Reducing agent reduces at a molecule, which means that molecule gains electrons. So it itself is being oxidized. So when you have a reducing agent, it reduces another molecule, as the name suggests. So when it gives electron to something else, itself, it loses the electrons, so it's oxidized. So it's called a reducing agent, and is thus oxidized. Oil, oxidized, lost electrons. It lost electrons because it gave it away, so it's being oxidized by this process, while the receiving agent is said to be reduced. The one who will receive this electron is going to gain electron, so it's going to be reduced, reduced. And the last question, why does the electronegativity decreases down the group and increases across the period? That's what we talked about in the last question with the fluorine. So first of all, why it decreases down the group? So it decreases down the group because, as I said, larger atom it will have less nuclear charge. It will feel less nuclear charge because if we have lots of these rings, then these electrons are far away from the nucleus, which is positive and wants to attract these electrons. So the further away it is, the harder it will be for the nucleus to attract it. And it also increases across the period. It increases across the period because even though the electrons are still in the same shell, however many you have, whichever one atom you're looking at in the same period, so it's going to have one shell, more electrons, more positive nucleus. So the number of protons keeps increasing, so the nuclear charge increases, because there's more and more protons. Therefore, we have a greater attraction. We have more of these protons. These protons attract these electrons, which are all in the same shell, even more and more and more. That means that it's easier for this atom to attract the electrons. I hope you understand this. It's kind of difficult to really explain because there's a lot to think about. The solubilities, the electronegativities, melting points, observations, reactions, flame test. That's really a lot. So it's best to, as I said before, it's best to keep it as your last topic. This way, you're just gonna remember it for your exam. So write it all over again and again and again. The more you repeat it, the more you repeat all the colors, the quicker it will be for you to remember them. So that was everything for this video. Remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I leave all the links in the description box below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. I hope you'll like my videos, subscribe, and see you soon. Bye!